We are still skimming the book, and this chapter is about Microsoft Azure. Uh, we wrote our first code in the previous video. Now we are going to look at HTTP events in two parts. The first part is called webhook as a trigger, and the second is called API as a trigger. So a webhook is simply a method of changing the behavior of a web application or web page with custom callbacks. The callback are functions passed to functions. Callbacks are functions passed to functions that signify the end of a specific task. Some tasks can be done in parallel, some tasks have to be sequential. The callback specify that. And here's a small figure 423, that shows the callback signifying the end of a function and start of another function. Right? All right. The custom callbacks we will use for our webhook will be maintained, modified, and managed by GitHub. Microsoft GitHub. Okay. For the purpose of this exercise, we are going to use GitHub triggered webhook to gain a better understanding and of how we can utilize. So we would like to understand how we can utilize in our Azure functions and how we can use a third-party sources like GitHub to configure them. So basically, we need an account, a GitHub account, and it should be free. Create a GitHub webhook trigger. Right? We need to create an account in the GitHub. Select in Azure, Microsoft Azure, select the GitHub webhook template from the Azure library. So what are we going to select? GitHub webhook JavaScript, a JavaScript function that will be run whenever it receives a GitHub webhook request. Okay. And here we can create account through the www.github.com, and here is some clarifying paragraph, and we'll just go through that real quick. And here's the GitHub account creation, and here past URL and secret to your GitHub webhook settings. So we have all right. So what events we can create to trigger the webhook? We have so many triggers, including commit, comment, create, deployment, fork, golem, issue comment, issues, label, member, milestone, page build, project card, project column, public, pull request, push. In this example, the author is going to use, or used, because it happened already, the author used push. All right, and we have the release and the repository and status and team add and watch. What is recommended by the author is to try other things, not just to be limited to the push that the author give us an example about. All right, so let's keep going. The author said, I choose push event for my webhook, but feel free to try something else. All right, so in the Azure, the log shows webhook trigger and execution. All right. My functions body simply writes the request to the logs. You can see everything about the push to my repo, including committer, timestamp, and what I changed. This may not be so helpful right now, but you can see how webhooks could be used to set up GitHub apps that describe to various events on GitHub. These applications can be used to update an issue tracker, trigger continuous integration builds, and even deploy to different environments. This example wrap up for GitHub webhook example. If you are interested in learning more, I found this to be a good resource, and there is an article or some writing on this link. Build upon our Hello World API trigger. So we are done with the webhook trigger. Now we will do the API trigger, the other half, right, in the HTTP. To build our HTTP trigger, we are going to create a notification service that utilizes Twilio. Twilio is something that sends SMS. In Microsoft Azure, Twilio is used. In AWS, something called SNS or something like that is used. We will see that. All right. So basically, Twilio can be used. It's globally. It's a service, a third-party service that allows you to send text messages. It's used to confirm the phone number and just like that. So it is used for verification and authentication purposes. To pull our HTTP trigger, okay, we read that. To create a notification service that utilizes Twilio and the Hello World API trigger, as well as output bindings. I'm going to make this service fun and say it will be a food delivery notification service. So for the sake of example, it's going to be a food delivery notification service. So when the food gets delivered, it texts you, send you a text message, right? An SMS. All right. The author said, I like to separate my API calls into different functions. Since the goal of delivering serverless solutions is fast, event-oriented design, we will stick to this approach. To begin, we will configure our function. So navigate back to your Hello World function, do the following reconfiguration. So things needs to be changed, of course. And no need to say that a Twilio account needs to be created, just like the GitHub account needs to be created, right? So the changes on the function in integrate navigate to triggers, change your allowed method to selected method and choose the post method. I set my route template to be orders. Feel free to do the same. In outputs, click add a new output and choose Twilio from the available outputs. For message parameter names, use the function return value. You can also set your own parameters. I left Twilio settings as Twilio auth token and Twilio account SID. I also left the rest of the parameter blank so I can configure them in my function. And here's the Twilio creation part and something called auth token and SID can be taken from after creating an account in Twilio, and that needs to be written in our Azure. All right, copy the two tokens from Twilio console so we can use them in our function. And I'm going to break here for a Twilio plug. Twilio is a unique developer platform for communication. Who uses Twilio? Netflix, Uber, Lyft. They all use Twilio. So Twilio is used for many applications. What AWS, Amazon Web Services, use as a Twilio, they use something called SNS, right? After you grab your tokens from Twilio, save them in your application settings. I saved mine as Twilio auth token and Twilio account SID. You can name whatever you like, but you will need to configure this in your function inputs. So here's in the Azure, and we save the auth, like here. Twilio auth token, Twilio account SID. Yeah, just like that. So basically, this will identify the Twilio account to the Azure account, like we connect them together. To be able to use Twilio integration effectively, we will need to get an outgoing phone number from Twilio. They will provide one for free, right? Very nice. If you navigate back to your function, we are going to configure the function.json file for the Twilio output binding. So the JSON file needs to be configured for Twilio. The Twilio output binding has a specific structure that we will follow to be able to incorporate our function. The function.json will provide the following properties: the name property and the type property. So the type must be set to Twilio SMS, the name, variable name used in the function code for Twilio SMS messages. The SID, this value must be set to the name of app settings that holds your Twilio account SID. Auth token, this value must be set to the name of an app setting that holds your Twilio authentication token. By the way, Twilio can be used by mobile apps and web-based applications, so it doesn't matter. It's a service. The to field, this value is set to the phone number that the SMS text is sent to. The from field, this value is sent to the phone number that the SMS is sent from. Direction should be out because we are sending. The body, this value can be used hard code the SMS message. If you don't need to set it dynamically in the code for your function. And in this case, for the sake of simplicity, it's written in the program, so it's hard coded. Usually, it's a variable that passes a string that entered in a way or another from the user, right? My final function JSON file looks like this, and here is it. At this point, we should have all of the setup done, so we can actually read the function. To start, we need to require Twilio, so we can use Twilio client to send them the message. For there, we will simply take the data we are receiving, parse it, and send in the message. The body of your index.js file should look something like listing 4.1, which is this one here. This is the body of index.js JavaScript file, right? Says hello plus request dot body dot name, hello the person. Your order of request body order is on the way, right? Yeah, just like that. So client.message.create, it has the from, the to, the body, yeah. Twilio. And here we type process.env.twilio account SID, process.env.twilio auth token, right? We will also need a package JSON file, the JSON file, since we are using node modules. Once we have flushed this out, the trickiest part is actually uploading it to Azure. This is where Azure gets a little tricky. Right? Once you have your index, functions, and package JSON files in your project in the console, navigate to function name.scm.azurewebsites.net. This is your functions URL with kudu to give a bit Background, Kudu is a deployment framework that can be triggered by Git. It is actually very similar to Visual Studio Online. I used VS Online at my client site and saw a lot of parallels between that and Kudu when I first started using Kudu. All right. So Kudu is a deployment framework that can be triggered by Git. Keep this in mind. You can check in the code, create a build definition that will build and run the code and test. Then proceed to push the content to Azure websites. Another benefit of Kudu, which we will see, is the ability to have more access and control over your code online. More access and control over the code. One of my biggest frustration when I first started working with Azure was not having control over my project. I spent a lot of time looking up solutions to uploading node modules and trying to physically upload them through the cloud shell to no avail. I even emailed someone, a mentor, and asked, all right. When I finally found the solution online, it was to use Kudu. So the solution is to use Kudu. For what? To access and control your code online. It was to use Kudu to interact with your code directly. We are going to do this now, so we have a better understanding of both how to navigate and access your code in the cloud and the benefits of Kudu. All right. So we are going to learn two things at the same time. When you first get your site, you will just see the dashboard. We will go into the debug console, figure 430, which is this one here. This is the debug console. No, this is where is the 430? Text from Twilio. Anyhow, to be able to access your code, navigate to the root of your application with package.json, and in the console use the npm install to install the npm package we need. So installing the npm package. This is what Kudu dashboard looks like when you navigate to the debug console. So here's the debug console. All right. So it's not 430, it's 429, right? This should be 429. Anyhow, note, if the npm install doesn't work, you can directly drag and drop your npm module folder into the Kudu project structure. I have had issues in past with the npm install from Kudu. So you can drag and drop the modules folder. Once your npm modules are uploaded, we can navigate back to the dashboard and test our function using the post body that we have used before. Mine looks like this. And the name is Maddie, the order is mac and cheese, the phone number is that, right? You can use the phone number and order, yeah, just like that. And to trigger the function, you send an HTTP request to the URL that is a combination of the function app URL and the function name. So to trigger the function, you send HTTP request to a URL. HTTP function app name .azurewebsite.net/API and the function name, right? And here, the function name is orders, like this part is orders here, right? And the function app name is beginning serverless. So this one as here in the beginning serverless. And once we run it, we get a text message, and it looks like this. Text from Twilio messaging application. So you'll get on your phone number a text message, an SMS. This is a wonderful, and when you receive it, you write a function and it sends you a test message. It's really a great happiness, right? In the next exercise, we will build storage trigger functions that will connect with this application, and this will be in a separate video. Before doing that, before going to another video, things to be added to your function. So this is just like an exercise or things to try. Build of this function to add more methods and Azure functions, proxies, a preview feature that allows you to forward requests to other resources. You define an HTTP endpoint just like with an HTTP trigger, but instead of writing a code to execute when that endpoint is called, you can provide a URL to remote implementation. This allows you to compose multiple API resources into a single API surface that is easy for client to consume. This is particularly useful if you wish to build your API as microservices. A proxy can point to any HTTP resource such as, examples of HTTP resources such as Azure Functions, API apps, Docker container, and any other hosted API. To learn more, go to this Microsoft article, right? And in the next video, we will be talking about the storage events. See you later.